Alright, this video is meant to help us with a large idea that we've been working our way up to. It's called linear programming. It's an idea that's going to incorporate not only graphing inequalities, but finding points of intersection, also picking points from a feasible region. Again, the region of all the shaded area with all the answers in it for constraints or inequalities. And then taking those vertices and plugging them into what's called an objective function. And the main idea is we want to maximize or minimize, and on this problem we actually want to do both, the possibilities that we can get back from the objective function. We want to know what's the highest or lowest value we can get back given possible vertices restricted by, of course, those constraints. So step one to working with linear programming is to take the constraints, if you're given those constraints, and to go ahead and graph them. So I'm going to start with the one in the middle, because notice that y is greater than or equal to 1 is just a horizontal line. So that's fairly easy to graph over here out at y equals 1. Then the equation at the top, or the inequality at the top, y is less than or equal to 2x plus 1. Well, I can start out at 1 here with a slope of 2 and just work my way up on my graph there. And notice that because y is less than, I'm going to be shaded below that line. But again, y was greater than for the horizontal line, so I'm above. So I'm somewhere out here in quadrant 1 between those two purple lines. Then the last line starts up at 6. So 2, 3, 4, 5. Here's 6. And we're going to be sloping with a -1 slope. So down 1 over 1. Down 1 to the right. And we'll actually run into 6 over here as well, which means that the point we crossed at there was 5, which will be helpful for us, considering that where those two lines come together will be a corner of that feasible region, assuming that it touches the shaded region. So again, we need to look at the fact that y is less than that line, so I'm going to be below the red line, and technically only anything in this yellow region, in this sort of triangular region here, only the points in there are in the feasible region. Now, we could pick random points in the feasible region. A point such as 2, 2 would be a good point, and we could put that onto our table if we'd like to. But there are formulas and theorems out there that will prove to you that can tell you that the maximums and minimums from your feasible region, assuming it's a bounded region, will come from the vertices of that feasible region. So I also definitely want to pick my extremes, or those vertices, such as 5, 0, or sorry, 5, 1, make that. I don't know why I said 0. Technically we're up a point. 5, 1, 0, 1, and of course we need to find that point at the top. Now that's the point where my two larger equations, my two y equals mx plus b equations, these two, crossed. So you could do that algebraically if you'd like. We could do that by the method of substitution, since they're both equal to y right now. And we're only worried about where they're equal. Don't worry about the inequality. It's where those two actual lines cross. Or we could jump onto our calculator real quick, as I note down here at the bottom. And I've got all of my different regions graphed here. Remember that we're going to be in this triangular region. But remember, if we hop on here and say Menu, Analyze Graph, we want to find a point of intersection. And now because I have multiple things going on here, first thing it's asking me is which graphs would I like to use. So I'm going to click on my blue line here. I'm also going to click on my yellow line, so that now my calculator knows I want to know where those two lines cross. So now lower bound, upper bound, and you'll notice that I get a point at about 1 2/3, 4 1/3. So this point came out to 1 2/3, 0.6, repeating here, and 4 1/3. Oops, decimal point there. Which means that's what we're going to put down here on our graph. 1 2/3, 4 1/3, down here on our table there. Now the last thing that we need to do for linear programming is take those points and plug them into our objective function. So we need to say, well, here's my function, 2 times any x value, so 2 times 2, plus 2, and see what we get. So I'm going to do that for each of my points. 2 times 5 is 10, plus 1 would be 11. 2 times 0 is 0, plus 1 is 1. And 2 times 1 2/3 plus 4 1/3. Well, that's 2 makes 3 1/3 plus 4 1/3, which should be 7 2/3. And then the last thing I need to do is, again, find the minimum and maximum values of the objective functions subject to the constraints. Well, my lowest value that I got was a 1. So I'm going to say that my min value equals 1. But the largest value that I got was 11. Max value equals 11. And there are my min and maximum values from my linear programming. Now, linear programming can be a little bit more difficult only if they give you a word problem or an application problem where you might have to set up the constraints and set up the objective function first. So here are some basic steps to linear programming that I would recommend using. And again, the stuff in green at the top and green at the bottom is just assuming that you're actually solving a problem using this out in the real world. So go ahead and pause the video now and you can record those steps. What is in blue is what we've already done on the previous page. The only new additions would be deciding what you want to use for X or Y, naming your variables, setting up those constraints, and then of course interpreting your answer at the very end, whether or not you want the min, the max, and how it's going to be interpreted in the real world. Now, moving forward, to go ahead and use that, here's one example of doing an entire linear programming problem. And I'm going to pause at various moments and kind of fill in gaps. So just kind of follow along and feel free to pause and record as needed. So take a second to read through your question. Then we want to identify what would we like to use for the variables. And for that, what I normally look at is the final question. Determine how many small and large quilts she's going to make in order to maximize the profits. So my objective function I already know is going to talk about profit. I also know that I'm going to be making small and large quilts. So X can be the number of small quilts, and Y could be my number of large quilts. Then from all that given information, all those numbers up there, see if you can't set up a couple of constraints. Alright, so over here at the left, again, I've decided on my variables, so I just went ahead and looked and said, well, I'm limited on my amount of time. I only have 324, Louise only has 324 hours to make these quilts. Realize that small quilts take longer than large quilts, but if we set it up, 36 hours per small, 27 per large, and we're limited less than or equal to 324 total hours to use. Same idea goes for the yards. Again, it takes less material to make a small quilt, more to make a large. So as you notice, if we make lots of large quilts, we're going to run out of material quickly, even though we could make more of them depending on the time. And that's sort of backwards for the small quilts. They take longer, but they use less material. So our question is, which one do we want to concentrate on? What's going to take more time, or what's going to take more material? Also realize that in our basic idea, we can't make a negative number of quilts of either type. So X and Y both need to be greater than or equal to 0. And as far as our profits go, we also make less money on a small quilt, but you want to keep in mind the fact that you might be able to make more of them, thus making more money due to numbers. But the profits overall will be determined by $100 per X and $125 per Y. Go ahead and take a second and graph our constraints and see if you can't come up with the vertices for the feasible region as well. Alright, as you see, I've done most of the work here already. I went ahead and used intercepts to graph my two lines. So for my green line, plugging in 0 for X, dividing by 27, I found that we had a Y-intercept of 12. Doing the same thing, plugging 0 for Y in, so 27 times 0 disappears. Dividing out that 36, X comes out to 9. Did the same thing for the orange equation. Plotted those points, crossed my lines, and realized that again, we're shading below both of those lines. If you check 0, 0, 0 will be less than both 324 as well as 0 plus 0 being less than 96. So we're in the shaded purple region here. Then I went ahead and used my calculator knowing that I'm going to have vertices at 0, 0, 0, 8, 9, 0. I needed to know this intersection point. So if I go on my calculator real quick, notice I've got my two equations graphed in blue and in red. And all I have to do, again, is say control, actually no control, just press Menu. Oops, Menu, there we go. Analyze Graph. Find the point of intersection. Again, it's going to ask you which ones, because I've got multiple lines on here. So I'm going to click on the blue and the red, and then do a little left bound, right bound, and find that my intersection point is at the point 6, 4. Now, you'll also notice that on my main screen, I've taken those points then, 0, 0, 9, 0, 0, 8, and 6, 4, and plugged them into my objective function. Now, if you don't want to do that by hand, another great shortcut for you, if you'd like to use it, is just open up a table. So we can open up a list and spreadsheet page, and then go on here and go ahead and enter in your points. So knowing that we want the points 0, 9, 0, and 6 for our x coordinates, and you can put in a label for x, that's never a bad idea, 0, 9, 0, and 6. Then for my y coordinates, notice we wanted 0, 0, 8, and 4. 0, 0, 8, and 4. So you'll notice we have our proper points there. If I go up into the gray region for my objective, if I go into the gray region, I can type in my objective function, 100x plus 125y. 100x plus 125y. And you'll notice that the x and the y are recognized as those two variables we used as our list names. So that now, when we press down, and it's going to ask me, do I want to use those as a column reference or as a variable reference? I'm going to go ahead and say column reference. I believe that's correct. And it should give me, oh, that was incorrect actually. Sorry about that. So let's go ahead and put this in one more time. 100x plus 125y. And when you hit enter, we actually want to do a variable reference. This should work out for us. Well, again, a little bit of a problem there. As you can tell, I haven't done this for a while. So let's go ahead and type in 100. And try hitting our variable button. There we go. Now we can put in x plus 125 variable. We'll pick our y. And it still doesn't seem to want to do it. Well, that didn't work out too well now, did it? Well, there is a way to do that. It's not going to look real great in the video, but it would work out for you, and you should be able to get your column typed in there. You might have to use an equal sign or something. I'm going to have to look into that one. Last thing to do though is interpret our results. Notice that our maximum comes out from that 1100. So determine how many small and large quilts. Well, we should make 6 small and 4 large quilts. And that will make us the most money to make $1,100. There you go. Hope that helps with linear programming. Good luck and have fun.